Hello, everyone. Welcome to the Professor Messer Network Plus study group for the month of February in 2013. This is our second study group of the year. And I think this study group is one where I've had more questions on the Network Plus side than ever before. I had to parse a lot of these things out. And I've been noticing a lot of things happening through the month, different questions coming in from different places. I've been trying to save those. So even people that didn't think they were asking a question for the study group, I put it in the list anyway. So there's a lot of good things there. If you're watching live, I am looking at the chat that is on the Professor Messer website. So if you go to Professor Messer, there's a chat at the bottom. I have opened a room just for this that says the Live Network Plus Study Group. So I'm watching that chat go by. That's the only one I'm looking at. So if you're somewhere else right now, and you're typing something in, I'm not seeing it. So make sure you go there. If you're not watching this live, join us. You can always check the website at professormesser.com. I have a calendar at the top of the page, or you can go to professormesser.com/calendar, and hopefully I will have updated it with when the next live event will be. We tend to do these on Saturday at 12 noon Eastern or somewhere around there. Sometimes the times move, so make sure you check into the calendar and you'll know exactly when we're planning to do the next event. That's one of those things that I never exactly know what's going to go on in my life, so I try to get it at 12 noon every time. It's been working out so well. So far, so good. One never knows how that's going to be. The study group that we're doing today is one that we're doing every month. It's one I like to just sit down and do a live event, get everybody on the net. You send me your questions, and we go through all of those questions. And I'm able to do this because of you coming to the website now and watching all of our videos. I get a number of questions that come in on the study group questions that ask, are all these videos free? Can I watch really an entire Network Plus training course? Does it go through every possible subject in the training course and they're all free and available and I can watch on YouTube? Every single one of them? Absolutely. Every single minute of these training videos that I make go right onto YouTube. You can go through an entire training course that, quite honestly, you could spend hundreds of dollars, I guess, buying a training course from someone else, or you could just watch it for free online. And it's your support of doing that that allows us to have these study groups and do these things. There is also people that need to take it offline. Maybe they need it for a classroom use. Maybe you are on a train and you don't have good internet, and maybe you'd like to take it with you on your commute. I also have downloadable versions. So you can go to professormesser.com/download-network plus to download that. And I have different things that I do and send out over Twitter. You can follow us, professormesser.com/Twitter, even on YouTube, professormesser.com/YouTube, Google Plus, professormesser.com/Google Plus. Just type professormesser.com/something and you will get to me. I try to figure out all of the different possibilities that you could get to be able to do that. And that's one of the things that I think is important for you to be able to access this information, regardless of what social network you happen to be on. If you're not on any of those social networks, that's fine too. Just come to the Professor Messer website. I try to do everything out there that we can do. When I do these every month, I ask questions, but I tend to get questions from people who asked the same thing previously. Then there were previous study groups. We've done about a year of them now. And if you go to the Network Plus index page, you can see all the study groups that we've done. And we get a lot of repeats. So there are certain topics I will not be covering today because I covered them last month. And I just wanted to review really quick and let you know that one of the questions that we did last month is distance the only advantage in using single mode over multi-mode fiber optic cable? What's the differences between logical and physical network topologies? Could I talk about Wireshark? We're going to talk about Wireshark some more to this month as well. I can't miss that one. What's the difference between a hub, a switch, and a router? That's an important one for your Network Plus certification. Do you need a lot of experience to pass the exam? That's a pretty important question if you're planning to sit down and take the Network Plus certification. And does the A Plus or Network Plus count towards any other certification? All of those questions were handled last month. We will not be covering those this month. So if you have an interest in any of those, the replay's online. Of course, I stick it on YouTube. Everybody can watch it and go through that as well. This month, we have a completely different group of questions. If you already have your A Plus certification, you already have your Network Plus certification, and you would like to get credit for watching this towards your continuing education units, then you can apply for that with CompTIA, and it applies. You can go to certification.comptia.org/CEUFAQ. and get information about how that would apply. If you have an A+ certification, you can have up to 4 CEUs. If it is a Network Plus certification, it is up to 6 CEUs that you can get. So pretty nice to have that capability even there. A lot of the questions I get every month, just so you are aware, I've answered a number of these on the Professor Messer website. If you go to professormesser.com/FAQ, there's a number of questions there like what topic should I study? This mentions specifically some A+, but I think it also applies towards the Network Plus too. Are these videos updated with the latest content? How much does the exam cost? I failed my exam. What should I do now? I hope you're not in that situation, but if you are, I've answered that for you. So you can see those things and be able to do that as well. There's some good questions there, and I think that's one of the things that I like to have people participate in so you can see what those questions are like and be able to work with those. I also like to ask questions of you. So if you're participating in the study group today, grab your mobile device, grab your iPhone, grab your Android device, pop open a new tab in your browser, because now I'm going to have you participate in these things. I have a question for you, and my first question today, we're going to have a lot of questions today, but my first question for you today is, how long have you been studying for your Network Plus certification? I want to know this from you. Don't put it in the chat room, but I want to know from you how long you have been studying, because I want to get feedback on the things that you are doing. So go out to the vote.rs, VOT.rs, a nice little short URL for what you are doing in the in voting, and you type in 972984, or if you have a QR code reader on your mobile device, point your camera right at the screen and it will take you to that page, which makes it kind of nice as well. That is one of the things that I think is nice about this, is that I can make it a centralized place to come for a study group, but now you get to answer some questions as well from me. Let's bring up this link that I have here. This is the Network Plus certification. This is one I think we can just start seeing the results right now. You go to VOT.rs at 972984, and here are some of the results that have come in. This is usually what we'll see is a lot of people are just starting out at trying to learn more about the Network Plus, and we certainly see that in this view as well. We have a lot of people that are also been doing this for a while. These are the folks that are like me. When you're working on a certification, a lot of people have a lot of time. Maybe you're in school. Maybe you have a lot of time during the night. You can study and study and study and get that. Others of us have a day job. There is a family. There is a night job. There is a lot of things going on. You can't just get it done in 3 months. This takes 6 months. It takes a year. Plus, when I like to sit down and take a certification exam, I want to know that stuff cold. I want to walk in. I want to kill it. I want to get exactly a 100% pass rate. At least that's what I'm striving towards. I haven't quite hit that yet with all of them. But I do a pretty good job, I think. I want to walk in and know what I'm doing. So I like to spend a little more time studying this. And you can see in our group today, we've had less than 3 months, 12 of you, less than 3 months, 6, 3 to 6, and 5, 6 to 9. It kind of goes off from there. So that's good. A lot of the things that we're going to talk about in the study group this week will be very specific around those types of pieces of information that you need in the first 6 months of what you're doing. And there's some pieces in here that will help you throughout your career. So I tried to mix it in with a lot of the different pieces that are there as well. I think that's important to get it too. So now I want to kind of step through a lot of the questions that you have. Oh, it went a little bit too far there. I have another question for you. We're starting off with a question right away. Is I want to know, This is I get questions about IP addressing and subnetting every month. And so I thought I'd give you a question on IP addressing and subnetting. And the question is, what class of IP address? Don't answer in the chat room. Do not answer this question in the chat room. You want to answer online. You want to answer what class of IP address? 165.192.10.172. What is the answer to that? So make sure you either use your VOT.rs and go to 918878 to vote, or click the QR code reader right there. So the real question is, and the options that you'll have available to you are these. You have, is this a Class A, a Class B, a Class C, a Class D, or class is dismissed? What is that? It's one of these 5 answers here. Make sure you don't mention this on the chat room. You want to mention this right here. You want to go to vot.rs and vote at 918878. What class of IP address is 165.192.10.172? It's important to know the classes because you will use these later on when you start thinking about doing more detailed subnetting. So it's nice to know what these are. We don't use a strict class-based subnet masking to determine what a subnet mask is any longer, but they're very helpful to know when you start doing your more advanced subnetting throughout this time. So we've got 29 respondents. I'm going to click a button and let's see them. So far, let's see. We got 2 in Class A, 4 Class C, 2 Class. 1 class is dismissed. There's always one person, isn't there? I know you're out there. You've now voted. I see. We're already starting that. 24 of you weren't fooled at all. You know that 165.192.10.172 is a Class B address. I look at this Class B address. This is one that is kind of close to some of the things that I've done. I worked with a Class B IP address subnet mask at one of the very first jobs I had, and it started with 165. So that one is burned into my skull. That's one of the things you'll notice a lot when you start working with IP addresses is over and over and over again. As you start to do more subnetting, it just becomes more automatic. And it's very frustrating when you're starting doing subnetting and IP address calculations because it seems very daunting. There's a lot of binary math involved. There's a lot of larger concepts of subnets and VLANs and routing. And you just have to kind of take it all in. It takes a while to figure it out. It took me months to kind of get into the groove of what this was really trying to tell me. And it really speaks to the question I got this month from DV that said, could you explain these different classes and ranges of IP addresses? And I want to explain them for you to be able to take this into your Network Plus exam. Don't overthink subnetting on the Network Plus exam. Before I answer this question, in fact, there was an email I got from somebody this month, just a few days ago, and I'm sorry I didn't write down your name. I've still got this email in my inbox that said, thanks for the videos. I watched the Network Plus videos. Everything was working, went great in the exam. I listened to your previous Network Plus study groups, and one of the takeaways was don't worry so much about subnetting. Because if you look at the Network Plus exam requirements, and we will do that later on in this study group, if you look at the exam requirements, it's a tiny, little tiny piece of the exam. And one of the things that I've said in my previous study groups is if you don't get subnetting, go on, move on to the next thing. You might be asked one question, you might get 2 questions about subnetting. This particular person said, I'm glad you told me that. I got no questions about subnetting. Now, your exam is going to be random every time. So I can't guarantee, like this person, that you'll only get 0 questions about subnetting, which would be great. You still have to prepare for these things. But I thought that was a good example that kind of goes back to what I've said in previous study groups. Don't worry so much about the subnetting. Worry about all those other things on the Network Plus exam. Really something. So the question was, could I explain the different classes and ranges of IP addresses? And if you've been to and looked at the Network Plus certification that I have, you've seen this chart. And it goes through Class A, Class B, Class C, Class D, and Class E. Now, if you look at this, you'll notice that there's this idea of still counting the bits. And I put a column, the second column in here has leading bits. Let's see if I can do this on my screen. There we go, the leading bits. I'm kind of reaching over here. I've got too many things on my screen. These leading bits will tell you what bits in the subnet mask you are using. But if you aren't into the binary thing, just ignore that. The thing that is probably the most important for us humans that use 10 fingers to count with in the base 10, where we count 0 through 9, 10 through 19, is these numbers underneath it. The leading bits, or the number 1 through 126. If the IP address starts in that first octet, in that first number, is a 1 through 126, it's a Class A address. So if it starts with 11 dot something, it's a Class A address. If it starts with 120 dot something, it's a Class A address. If it starts with 126 dot something, it's a Class A address. That's all you have to know that it's Class A. Now, there's all these other things in here, the size of the network number, the size of the remaining bit field, all of these other pieces in here. Don't worry so much about them immediately. When you start doing more subnetting, this will help you, and you should know it for your Network Plus exam. But for the purposes of answering the question that was asked of us earlier about the classes and what IP address count in them, just look at those two things. So let's go to Class B. I gave you the question earlier, what is 165.something.something.something? That fits right into the Class B, which is a number 128 through 191. Now, wait a second. It went 128. I went from 126 to 128. Wait a second. I missed a number in there. There was a 127 in there somewhere, wasn't there? 127 is used for private addresses on your computer. This is internal loopback addresses. This is an address that you can ping locally, and your computer should be able to respond back to at least say the IP subsystem on your computer is working. We're not even talking out to the network card yet. We're not even talking out to the rest of the internet. Well, I just want to know, is the IP stack even working on my computer? And you think that may be some sort of an odd question. Is IP working on my computer? Then you've never run Windows before, because Windows, especially older versions of Windows, got very good at corrupting the IP stack, and it would just stop working. In fact, Microsoft had a reset process, and even still today in Windows, there's a reset process that will reset all of your IP configuration settings. So very, very useful to have that there. Class C is 192 to 223. Class D, it starts with a 224, 239. Class D is multicast. Multicast is where I can send out a single bit of data, and that data is replicated out to multiple devices on the network. It's a relatively complex process, but it is one that can come in really handy if you have a lot of control over the network and you need to take certain information instead of sending it out to every single person, which is what we're doing on this stream. If you're connecting and looking at this stream, YouTube has to send an extra stream for every person who starts up the stream. So if 10 people are on the stream, it is sending 10 copies of that stream. That is unicast. You're going out from one to one. Multicast would be great. What if YouTube could just send one little stream and everybody who wanted to see it would be able to grab that? That would be nice, but YouTube doesn't work that way. Multicast is much more complex than that, and unfortunately, it's not a method that's going to work well across the internet because all of the different devices and how we're using that. There are cases on the internet where multicast is working quite nicely, but YouTube is not one of them. And Class E is reserved, which means we're not going to use these IP addresses for anything. It's 240 through 254. And obviously the Class D and the Class E, we don't have to worry about number of subnets, number of hosts in a subnet, those types of things. They don't have a default subnet mask for that class. Those things are not incredibly important for what we are doing, but incredibly important to know because you may get asked what class in that class-based IP addressing scheme, what class is 240.1.1.1. Well, that's a Class E, a reserved class of IP address. And you won't see that on any networks because we have already, as part of the specification for IP, we have already said we're not going to use those. Those are reserved. We're not going to take advantage of those classes. Well, which brings up a good question. And it's a question that RG asked, which was, well, if we're running out of IP4 addresses, and we are running out of IP4 addresses, why can't we use then the Class E addresses? We'll take those Class E's and now we'll expand it out and we'll have more IPv4 addresses available. Not a bad idea. We could do something like that. Let's think about why we couldn't though. Now, as you're probably aware of, we're out of IPv4 addresses. It's very, very difficult, if at all. We're starting now to pull addresses back that have been given to people just so we can assign them to other organizations. That's why we created a classless IP addressing system where we don't have these very structured subnet masks that end every 8 bits on an octet. Let's look at this, for instance. If we go back to that chart, the default subnet mask for Class A, 255.0.0.0, Class B, 255.255.0.0, and Class C, 255.255.255.0. In a class-based subnetting system that we had many, many moons ago, those were the only choices you ever had for subnet masking. And in an effort to make this a little easier to deal with, make a number of addresses be much more efficient, we got rid of these default subnet masks and we allowed people to change the number of bits that were in a subnet mask. And that's the part that's really complicated and you have to do all the binary math. So don't worry too much about all of those pieces. The default subnet masks, though, we aren't really using those. It can now be anything. We could look at a 10.1.1.1 IP address. It might have a subnet mask of 255.255.255.0. That's pretty common to see in larger organizations. So you can't rely on that default. But let's go back to that question about the Class E. Look at this Class E reserved. Look how many we have available. It's 240 through 254. So I like the idea of grabbing these addresses and being able to use them for something else, but the reality is there's not that many there. It's not a lot to choose from. 240 to 254, not a huge range. Even if we grabbed them and used them, we really couldn't do much with them. They'd last 2 seconds. They'd be gone too. The real answer is going to be IPv6. We all know this. We're all struggling against it. We're all swimming upstream. We're all trying to get to this point. And some organizations are doing better jobs than others. But I think that's the thing that's really going to solve the problem. Also, because they're Class E addresses, you may find that the operating systems, the IP systems we're using, will see that IP address and say, oh, no, you can't use that. That's reserved. I can't route that. I can't do anything with it. My programming already tells me that's a bad IP address. So we really can't do that piece either. Really can't take more advantage of sucking away the Class E and doing something with it. Because at the end of the day, even if we use them, our machines wouldn't know what to do with them. They'd blow up. We'd have to reprogram the IP stacks, or at least do a check to make sure they were able to use them properly. So in the chat room, since I mentioned IPv6, the questions that come up, Benny asks, well, why is this so difficult? Why can't we just flip over and use IPv6? How hard would that be? Certainly that would be easy. And Robert's asking, when is all of this IPv6 stuff going to be more mainstream? And two very, very good questions. These are questions that have plagued us for years. IPv6 has been around 15, 20 years. It's been around a long time. We have had IPv6 standards in place for almost 20 years. I'm trying to think back of when I saw IPv6 added to a protocol analyzer, and that protocol analyzer was only available in DOS. This is prior to Windows. So this really is about 20 years ago. If somebody can do the math in the chat room and look at the RFCs, been around forever, but it is remarkably complex. It uses a much larger address range. This is not just an upgrade to IPv4. You are putting in a brand new set of protocols, which means your routers need to know how that protocol works. Your workstations need to know how that protocol works. Every router in between you and where you're going has to know how that protocol works. You have a lot of complexities. Now go the next step. What about firewalls? What about IPS equipment? What about phone systems? What about every device that has an IP address has to know how to talk IPv6, and not only know how to talk IPv6, but has enough programming and development effort behind it to make it solid, because it's really programmers that are building these stacks. On top of that, very large organizations can't just flip a switch and everybody moves over to IPv6. You've got legacy applications that have no idea how to operate in an IPv6 environment. You've got legacy operating systems that those are running on that know nothing of IPv6. And in the chat room, Robert makes the point, yeah, but don't these devices know about IPv6, these routers and the switches? Most of them do now. But even 4 years ago, there was not a huge number, not the industry-wide support for IPv6. Only in the last 2 years have I really started to see large-sized organizations begin to do a lot more with IPv6. And I'm going out and seeing a lot of organizations that are out there and what they're doing. A lot of others are saying we don't need it right now. We're good with making those things happen. So I'm fine from an IPv6 perspective. Now the IPv5 in the chat room, Sam asked, wait a second, you said IPv4, you went to IPv6. What about IPv5? There was a streaming type of IP modification that was called IPv5 It was standardized. It was one, I think, from Next. It was a Steve Jobs type scenario. I think it was Next that was doing it. Maybe I'm off on that in my IPv5 because it is now a footnote to history because it was already used in that. It's IPv6 that is now in use. That's now taking advantage of those pieces. So we just skipped the number because we sort of used that number for that thing that never really took off. So IPv6 it is. So that's kind of nice. And in the question in the chat room from John says, so is IPv6, is it going to take over our local area networks completely, or is it just going to be on the WAN? Where is this going to be used? So currently, here's how people are using this today. Within an organization, generally everything is still running IPv4, and people are starting to turn on the IPv6 functionality to start doing testing at the same time. Because it's on your local network, you have a lot more control over what you turn on and what you turn off in operating systems. There's a lot more management of the network. You can make sure your switches support it, that your internal routers support it, that your internal security technologies support it, and you can turn those on. I don't see anybody doing production IPv6 100% in their organizations quite yet. If they are, they're relatively small. These are not the larger organizations for those things. What I do see on more organizations are participating in the tests that occur every year. There is an annual IPv6 day. And on IPv6 day, organizations turn on or they make available their IPv6 communication out to the internet. And they start testing IPv6 sites. Can I get to Google through IPv6? Can I get to Yahoo with IPv6? Can I get to Reddit with IPv6? Can everybody talk to me in my web servers over IPv6? Makes it pretty important to be able to see those things as well. So whenever we start looking at doing IPv6, there's a sort of an inside piece that we have to think about, an outside piece of it. And as you go through Network Plus and also Security Plus to some degree, there's other ways to tunnel IPv6 within IPv4 packets. And there are different ways to handle the natting. I mean, think about all of these things you have to consider. IPv6 generally doesn't NAT. IPv4 does. If I'm getting out to the internet, can I tunnel IPv4 through the internet to an IPv6 host, which strips it off and from that point can do IPv6? There's a way to do it. There's a lot of different ways to go about those pieces. So it becomes very, very useful to make that. And it's interesting to see what people are doing on their IPv6s on that single day. And it turns out to be more than a single day, but very, very nice to be able to see that more and more people are starting to come on board with that. IPv6 will be great. I would love to do IPv6 everywhere, but currently we're still struggling against the IPv6 piece. And I guess that's one of the challenges we always run into when we talk about IPv4, IPv6. We're going through and looking at all those pieces. I think that's one of the things that we struggle with is when are we going to make the jump? When are we going to stop doing what we're doing? And when are we really going to do IPv6? And it's a good question. And it's one we're just going to have to watch and wait and see. Speaking of questions, I have one for you. Do not answer this in the chat room. The question is, what is used to advertise a wireless network? And you go to vot.rs, use the number 961103 and answer, what is used to advertise a wireless network? Your choices are SSID broadcast, WPA encryption, IPsec tunnel, SNMP trap, or those little videos before the YouTube actually plays. It's advertising, right? How do you advertise a wireless network? Go to vot.rs 961103 or click on your QR code there. Do not answer in the chat. We're going to flip over and look. We've got 6 people that have responded so far. The answers, again, SSID broadcast, WPA encryption, IPsec tunnel, SNMP trap, or those little advertising videos that play before you can actually watch something on YouTube. How would you advertise a wireless network? How does that work? So if you go to this page and vote on this, we've had 24 people so far, and you're looking over these pieces. Obviously, all of these technologies can occur on a wireless network, but only one of them is used to actually advertise the wireless network to you. So this is when you would bring up your mobile device, you bring up your laptop, and it lists out for you all of those wireless networks that are available. If you're in a residential area, you're in an apartment building, you see a ton of those pop up. That's what that's about. So the 36 of you that have voted, let's see the results. So 34 of you said, oh, that's an easy one. SSID broadcast. Nobody even went for IPsec tunnel or SNMP trap. I didn't fool anybody. WPA encryption, absolutely the one that we're not talking about. 2 of you said, yeah, it's encryption. Well, it's not encryption. Advertising a wireless network can be done to wireless networks that are absolutely in the clear. They do not need to be encrypted. So that was a sneaky one I put in there for you. So not exactly the case. I guess it would be good if you could see that though. Here we go. More buttons for me to press. There we go. Now you can see the answers. That helps a little bit, doesn't it? So a good job on that. You knew the answers to that piece. You knew exactly what the choices would be there. The real question that I'm asking, though, I'm asking specifically about this, so we have that in mind when we go to a question that was sent in this week, which asked, why then would you disable the SSID? Why in the world would you go through the process of disabling that? If you want to advertise, you want people to know that the wireless network is there, then there's some things that say, yes, you should disable that piece. But why would you really do that? And what is that really giving you when you disable the wireless network? Is that really, really helping you? Well, let's first look at what an SSID really is. Let's pop over to this list. So an SSID stands for Service Set Identification. This is a way to identify the network. So, and you've seen this if you go to a restaurant, if you look on your residential list, you'll see not only your wireless network, you may see your neighbors' wireless networks as well. It's usually something you can recognize. If you saw my wireless networks, you would not recognize it. I travel with a mobile hotspot. Do I have my mobile hotspot here? I do. So I've got this mobile hotspot. Here we go. So I walk around with this, and I'm in an airport, I'm in a hotel, I turn this on, and then all of a sudden anybody who's in my hotel is able to see a wireless hotspot that is named Token Ring. So that's a little bit of a callback to the previous days. So I can do high-speed internet, and everybody's looking, wait, is there Token Ring on this network? No, it's just a name I gave it. And everybody likes to have funny little names for their wireless access points. But generally, you might give it the name of your address or the name of something you recognize, so you can see it there. It becomes pretty useful to have it there. Now, you'll see the term BSSID as well. That stands for Basic Service Set Identification. A BSSID is effectively the physical address, the layer 2 address of a wireless access point. We can think of it as a MAC address, the media access control address of the access point. The end users generally don't see this, but if you're running something like me, you're running Kismac, and you can look at, let's zoom up on this, so you can see all of the access points that are running out there. This actually is mine, WATPOPWUAN, and the BSSID is that MAC address that's right there. So you can see exactly where that's coming from. So the question is, the SSID, the one that is advertising what's going on, is the one that is being sent out that everybody can see. So why would I turn that off? There's usually an option in your wireless access point that says something like, would you like to enable or disable the SSID broadcast? And you're usually configuring that right in the access point. Practically every access point is going to have that option. I don't even think I've seen an access point that did not have that option available, at least not through modern times, in being able to do that. And you turn it on so that people can find the access point very, very, very easily. Something simple. Now you can turn that off. You can disable it so that nobody sees it pop up in their list. So it effectively becomes invisible. You would not know it was there unless you were actually grabbing packets out of the air with a protocol analyzer and seeing people actually connect to that access point. So this brings up a good point that you can still connect to the access point even if it's not advertising itself. It's not sending out the broadcast, but I can go into a manual configuration on any operating system and say, I know you can't see it, but connect to this particular SSID, please. It's a way that you can still connect, but not be able to necessarily have it listed in that huge list that might come up. So because of that, it's not really a security measure. You're hiding the fact that you are there. But if you just look around enough, and somebody who's very knowledgeable at grabbing packets out of the air and looking at them can certainly see the SSID that's there. Very, very, very simple to have it there. Even if this is an encrypted wireless network, the access point still has to have that available. It's still either going to advertise or not advertise. You can still see somebody connecting to the access point, even if it's an encrypted access point connection, because the encryption starts later on in the data. You can't have it encrypted, otherwise nobody'd be able to get to it from that piece. So very, very useful to have that there. Now, it's important to keep this in mind because there are a lot of security concerns around wireless. You don't want to be in a position where somebody's able to see the data that you're sending over this wireless network. This has been the problem with wireless forever, is that we've always been concerned about people grabbing our data out of the air and doing something with it, and it continues to be a concern. These days, you have things like this. There are some applications that you can run, most of them in a Linux type environment. There are some standalone devices that will do this that act as a fake access point. So you think you're connecting to that Starbucks access point that you always connect to, but you're actually connecting to something else. And it might then be sending the data into Starbucks and sending it out the internet, but you have no idea. And because they're sitting in the middle, even if it's encrypted, they can decrypt the data, see what's inside of it, re-encrypt it, send it on its way. That's a huge man-in-the-middle problem. If you're getting into your security piece, you're going to learn about man-in-the-middle, and you're going to learn about evil twins. And this is an evil twin scenario where somebody has brought up this access point that isn't really what it says it is. It's the evil Captain Kirk. It's the evil Mr. Spock. You have to keep that in mind when you're working on wireless networks, that you want to use encryption and you want to use methods that people can connect to and use this in a proper way. That's why a lot of organizations use certificates on the workstation. They will create a certificate that has to check into the access point. If that access point doesn't recognize the certificate, or it's not designed to understand the certificate, it doesn't get on the network. So that's the way it works. I'm not an evil twin. I have no mustache, at least not today. If you watch the replay from last night, there was a little bit of stubble, but that's not really the problem we have here. You can see I'm the good one because I don't have a mustache. More questions. There is what access method is used on wireless networks? What access method is used on wireless networks? Do not answer in the chat room. Don't put it in the chat room. You want to answer the method that is used to do this. So the access method choices, if you go to vot.rs and you go to 605525, you have the choices of CSMA CA, DSLAM, CSMA CD, IPsec, and EIEIO. That one's probably not going to be the right answer, I'm guessing. You go to vot.rs 605525. If you missed, I'll leave up the little QR code so you can put that in there. Your choice is CSMA CA, DSLAM, CSMA CD, IPsec, and EIEIO. So what access method is used for wireless networks? And we got 19 people. People are thinking about this one. Not getting 30 people jumping in all at the same time on this one. Don't go. What are you cheating? You went to Google? Don't go to Google. You're missing the whole point. Nobody's getting graded. It's just for fun. Don't cheat yourself. Go out. What access method is usually used on wireless networks? You go to vot.rs to see that. The questions that have come in, 31 people. Okay, we got some people that said, okay, I've gone to Google and figured it out. Let me answer the question. I'm going to have to institute a strict no Google policy on the study groups. Oh, this is good. I now have across the board. So you can see 15 people have said CSMA CA. One person has said DSLAM. 10 people have said CSMA CD. 10 people have said IPsec. What access method is used on wireless networks? And in some degree, it's a little bit of a vague question, I admit. But the access method, we're talking about the network access method, not any other type of access method for wireless networks. And the options here certainly are ones that we can think about. And I thought there would be definitely people thinking, is it CSMA CA? Is it CSMA CD? Didn't think there'd be 12 people that said IPsec. Let's see what the answer might be then. But before we do that, we need to understand more about what these things are. This is a pretty good question for Network Plus. You need to understand both CSMA CA and CSMA CD. These are crazy abbreviations. If there's one thing that you're going to see on your Network Plus exam, it's a lot of abbreviations. Fortunately, all these abbreviations are on the exam objective, so that should be good. The reason I asked this question and wanted to go down this road was MG asked this week, I used to think that Wi-Fi was CSMA CD, and now it's CSMA CA? Wait a second. Really? Is it CSMA CA? And in fact, that is the answer. For those of you that were wondering, the 19 people so far that have said CSMA CA, you were correct. But why were you correct? And why was it not some of the others for that? So let's look at what those differences are between those two. See, there's a method to my madness. They're in the chat room like, wait a second. I don't know what these, don't worry. I got you covered. I got you back. Let's step through it. Each one of these abbreviations, even parts of the abbreviation, means something different. As soon as you decipher this, it's obvious. So let's step through every single piece of it. CS means carrier sense, which means we're listening on the wire. Is somebody talking right now? Is there carrier? Sort of an old term. We use it from way back in using modems and being able to communicate. The very first types of modulations that we did over the wire, we use that term carrier. So that carrier sense, CS, we're listening to see, is someone talking? That's what CS means. We're gonna communicate on this network, but we need to know, we need to be able to hear if other people are talking as well. So that's an important part of the communication process. I think you would agree. The MA means multiple access. This seems kind of obvious, doesn't it? Multiple access. It's a network. Of course, there's multiple access. There's more than one device communicating on the network. But of course, that's an important consideration on Ethernet, on wireless, on token ring. Token ring's not on the Network Plus exam anymore. But any type of networking you're using, there's usually a lot of different devices communicating at the same time. So far, the CSMA is kind of obvious. We know that there's going to be a carrier or people communicating. We know there's going to be a lot of them. So let's break this down a little bit. What is the CD? CD stands for collision detect. Now, the CD part of CSMA CD, collision detect, this word collision has had enormous impact on people's thoughts around networking. Don't worry so much about the word collision. Collision is a normal part of a half duplex Ethernet communication. There are some topologies that do not have collision detection as part of their configuration. I think back in the day of token ring, I think about full duplex Ethernet. Full duplex Ethernet doesn't have collision detection in those full duplex because there's no collisions. Collisions only occurred on Ethernet because on the half duplex Ethernet, because everybody was effectively sharing the same wire. And if one person sent data and the other person didn't hear anybody but sent data at pretty much the same time, and these signals met in the middle, that both stations would realize, wow, okay, sorry, I was talking, you were talking, you do this on your mobile phone all the time. Oh, we start talking at the same time. I'm sorry, wait. Let's back off. You start now. You go. Well, no, you go. Okay, now you start talking again. That collision detection piece is kind of important. Now, you would think, and in fact, the chat room, I am right with Michael because I thought the same thing. Now, wait a second. Wireless networks, those devices can talk at the same time. So collision detection, they can detect that there is a collision and back off and start doing these things again, right? Wouldn't that make sense on a wireless network as well? Actually, we're going to look in a second, not actually the way it works. In collision detection and CSMA CD, you only have to think about this in half duplex Ethernet. Full duplex Ethernet doesn't have collisions. Therefore, this is not the access method that is used. Obviously, CSMA would still apply, but the CD part, not so much. On wireless, it's CSMA CA. CSMA CA, still the CS, still the MA. Collisions are not part of it. We have our carrier sense. We have our multiple access because it's wireless, but we have CA, collision avoidance. It's not collision detection. We're going to avoid ever colliding in the first place. So you're driving down the road. That's what you would like. You'd like to avoid the collision. You don't want to have to collide and they go, oops, let's try this again. Everybody back up. Now you go. That's probably not a good way to drive. That's why the word collision, people don't like to hear that. It sounds like you're trying to run people over in the street. But collision avoidance would be a good way to do it. If we could still send data, but not ever have to worry about colliding with anybody else, that would be awesome. So the question that was asked earlier in the chat room, to be able to do this. And these pictures, by the way, in the chat room, were like, these are really, really tiny to look at. And you're right, they are very tiny to look at. I'm not going through the exact pieces of this, but if you look at, I got these right off of Wikipedia. There's the picture credit for the nice person who did this, JJ Garcia, TSC. Go out to Wikipedia and look for CSMA, CA, look for CMSCD. That's where those come from. And of course, they're in the videos of the Network Plus stuff. The collision detection isn't possible on a wireless network because of physics. Here's the way this works. So if you're a wireless access point, and people who do ham radio run into this, certainly, and it's the same problem for any radio transmission. So on a radio, you have a transmitter, you have a receiver. So you can transmit and you can hear things. That's the idea. Now, if you ever notice on ham radio, when you're on a walkie-talkie, you're on these systems, if you're transmitting, you can't receive. It's this half duplex type communication. If you are working in a wireless network and you're sending data, you have a receiver which could listen in, but the problem is that your signal is so strong coming out of your transmitter that the receiver can't hear anything but you. It's called common mode overload. It is one where we're sending this data. We can't hear anybody else. If it collided, we would have no idea because I can't hear anything else but this very strong radio signal that's coming from me. So that's why collision detection won't work. We can't detect collisions in wireless. We have to come up with some method to avoid the collisions on a wireless network. So one of the things that we do to avoid that is you have a central device, your wireless access point, and one of the methods that it can use to be able to avoid collisions is what we call a ready to send and a clear to send. Every device is on this wireless network. You may have devices on the wireless network that can't hear each other, but they can hear that central access point. So again, another good reason why you would need collision avoidance, because you'd never be able to know there was a collision anyway. So what you do is you check into the wireless access point and say, I would like to send some data, please. Would now be a good time to send some data? And the wireless access point says, well, certainly you can send data. And now you can send the data to the wireless access point. If somebody else in the meantime is checking in and says, can I send data? The wireless access point says, oh, wait a second. I'm waiting for this other guy first. Now you can send your data. So there's this round robin or check in and give you a chance. You talk. It's almost like raising your hand. Can I talk now? Sure. So give me what you'd like to do. Okay, thank you. Who else would like to talk? Raise your hand. Thank you. All right, you can talk right now. And unlike the conferences that I'm in, people take turns and they're nice about it. So this wireless access point's very good. So this does solve that problem where one station's over there, one station's over here. They can't hear each other, but they can both hear the access point. So really, really nice to be able to have that in place and be able to use that method of communicating on wireless so that everybody gets a fair shake. There's no problem with people overriding or over talking one another. Very nice to have that there. And if you'd like to know more about that, you can always go out to the CSMA access videos that I have for Network Plus, or hit Wikipedia. That's where I got those pictures from to be able to see that. Fortunately, on the replay, I understand if you're watching live, this is on the Google Hangout. Google Hangout is not high resolution, and I recognize that it's perhaps not as great as it could be. The replay will be full resolution. I've got this recording going right now. We're in good shape with that. There won't be any problems there. I also want to take some time, since we are talking about these certification exams and going through the certifications and understanding what we need to know about the certifications, especially Network Plus. There's a lot of command line things you need to know. You need to know how to ping. You need to know how to trace route. You need to know how to solve some of these problems with networking. And what's more important these days is that it becomes even more important to know these things, because now you're being asked some practical questions for the exam. You may not even realize this. At the beginning of the year, CompTIA applied some practical questions. You take about 3 practical example questions before you get into the multiple choice part. So before you even have a chance to do your click A, click B, click C, click D, they might bring up for you a box that says you need to see if this device is on the network and is communicating via IP. What would you do? And you're at a command line. You have to type in the proper command to see if that device is up and communicating to you. So you'd have to type in the proper ping command. Maybe they're asking you on the ping command, I would like you to have it run until you stop. So you have to know what command line do I use to be able to do something like that. Now that could be about a bit of a challenge to be able to have something there. You have to remember it. You have to do some practical hands-on with that piece. And I think that's one thing that a lot of people get trapped on. They want to know, how can I get more hands-on to be able to do these things? Now, fortunately, the folks at GTS Learning, who have helped sponsor this study group today, have these things called practice labs, where you can bring up an actual lab and work on it without having anything on your local network. Now, this becomes really useful to have this here, is because I'm not necessarily interested in putting a bunch of machines in my room. Maybe I don't even have a bunch of computers. Even virtual machines, I'm limited on what I'm able to do with it. These are real labs. They're interactive. There's real machines in the labs. I'm going to give an example here. Let's do one that I was just talking about testing connectivity. There's one about routing. There's a lab about routing that I'm going to show you once I bring up all of these things on my screen. This allows you to bring up Active Directory servers, there's Windows XP machines, there's Windows 7 devices, there's all kinds of machines that are on the network. And what they've done is build out for you an entire series of labs. I know this is really, really small, but they have labs that are set up here so that if you wanted to see, how do I test connectivity? They've already got the lab for you there, and they'll step you through every piece along the way. You click start, you click control panel, you click this, you click that, and you click the other. So that's one of the things that they've got live machines here that you can remote desktop in and do things with. So it looks just like this on the screen. Let me zoom up on that. So it looks like this piece. I'm running a Windows machine. It's on a browser. I don't have to do anything else to make this work. Really nice to have that available too. It's one of those things when you start worrying about how am I going to get through the labs. And one of the things they've done is, I've told you in the past about Freestyle, which is all of their books are online for Network Plus. You can read everything that's from their book online. They've taken my videos and embedded them into the book, and they were selling that for, I think, about $75, something around there, $65 US. What they've done is taken the labs and the book and the videos, and their Freestyle also comes with sample exams, test exams that you can take that are timed. They've made them all available now for $99. And it's a special for Professor Messer. If you go out to professormesser.com/netlabs, you can try this out yourself. You can log on and use the labs right now yourself. You can get them up and running, go through some samples of them. You don't have to buy anything. You can try out Freestyle for free. It's all of the things that you might want to be able to have online. You don't have to have a real book. All the videos are there. The practice tests are there. It's a one-stop shop. One of the things I've really liked about that is going to one place. Here's an example of the exams. I'm live on mine right now. So I can take there's my exam objectives. Let's take a prerequisites test. And drill down in it. It says, all right, you can answer. You ready to go? Yes, let's keep going. I started this in a previous study group. So it says, you left off. Which of the following represents the fastest connection speed? I should probably make this so you can see. Oh, you can see that good. So I get to choose. What is the fastest connection speed? And I have to remember, what is a megabit versus a kilobit? And what are the differences? You select one. Let's try that one. I think I got that right. We'll have to find out at the end. We'll go to the next. And go to the next question, what type of device? So you can go through the whole test and see how well do you know these things. This is a test of 20, and then you can, at the end, you can see how well you did. And then it takes you to the part of the book that talks about that topic, and it takes you to the video that describes that topic. So another good way to get feedback on how well you're doing. Again, if you want to know how to look at more associated with this, all the special pricing is at this link. professormesser.com/netlabs takes you to this link, shows you everything you need to know. You can get the samples from here. See if you like it yourself. You don't have to buy it right away. Try it out. And we appreciate GTS Learning for being a sponsor of our study groups. They have constantly been there and being able to provide us with more and more content, more and more information. The labs are now something that we've now had for a number of months. Great resources, especially if you're concerned about those performance questions that you're going to get. Let's continue on our study group with more questions about this piece, this month's acronym. Oh, for those of you asking, there's no coupon code. Just go to that link. You're done. $99. No coupon code. Makes it very, very easy. You have to go to that link, though. That's the secret, is professormesser.com/netlabs. The next question I have for you on this month's acronym, TMA, the acronym that I got as a question from you this month, do not answer in the chat room. You chat room people, no Googling in the chat room. So now we have a no Googling stance on the study group. What is EAP? What is EAP? It's a mystery, isn't it? What is EAP? Now, I've created for you options available. If you go to vot.rs, use 914250 as the number. EAP is one of these things. It is an authentication method. It is a cabling type. It is a wireless encryption standard. It's a routing protocol, or it's a brand of those biscuits that you get in a can. It's one of those. You could probably discount one of those immediately, I would think. So is it an authentication method, a cabling type, a wireless encryption standard, a routing protocol, or brand of biscuit in a can? Again, no Googling, no answering in the chat room. I'm chat room. I'm looking at you people. You can see. There you go. So this is one of those questions you will get on the Network Plus exam. They expect you to know what EAP is. We've had 26 respondents. I think that's good enough to show the results. 20 people were not fooled. They said, oh, that's authentication. We know EAP. And you probably know it by it's kind of a different name. There's some other abbreviations we put on the beginning of that. It is not a wireless encryption standard, alas. It is not a routing protocol. Nope, EAP is not. And for those jokesters, someone always chooses the E question, don't they? It is not a biscuit in a can, but I can understand why you would want to choose that. It is so appealing to have that option there. And who doesn't like biscuits in a can? That's what I'm saying. So the question really got this from KM. It says, what is EAP? And so let's look at this a second, because you see this on the Network Plus exam. EAP, not really that hard of a topic, thankfully. So this is in the chat room. How do you know I was Googling this? EAP, for those of you that did not Google EAP, it stands for Extensible Authentication Protocol. And you may be using this, especially if you're in a larger organization and you're connecting to a wireless network, you're probably using something like EAP. It is a method of authenticating. It's really a framework. I know it's called Extensible Authentication Protocol, but it's really more of a framework. It's not like a network protocol per se. It's a way that you can authenticate using some RFC standards. So one important part about authentication, and this is something that's used all the time in almost every environment, is this authentication piece. When you log in to Google Mail, there's an authentication that takes place. When you log into a wireless network at your place of business, there's an authentication that takes place. When you are connecting to a VPN back to your corporate environment, there's authentication that happens. Now, one of the challenges, of course, is that your computer is running a certain operating system. It's connecting to a VPN concentrator that's probably a completely different company, or you're connecting to a wireless access point, another different company. They're all communicating back and needing to authenticate to a central database. If this is a corporation, you're probably using something like Active Directory to authenticate everyone. So how do you make all of this happen? Well, you use standards, and EAP is one of those standards that allows organizations to build a framework that everybody can understand during this authentication process. You most often see this on wireless networks, but it is not exclusive to wireless networks. And in fact, you probably are thinking this now. Yeah, you'd probably see this more in a business environment to be able to do something like this. But there are, in WPA and WPA2, there's an authentication that takes place. And if you should be running WPA, or more importantly, WPA2 on your wireless networks, it uses EAP as the authentication method to get you onto the network. Very, very useful to have that. It's usually used inside a different protocol or a different method of communicating. The EAP part is the part that actually is doing the authentication mechanism. So how is this used? Let's take it out of the weird definition and take it into some practical examples. EAP. If you are on a wireless network and you are authenticating in and being authenticated on the back end by some other type of central database, it's probably using a protocol called 802.1x. This is a network access control protocol, and that network access control mechanism is authenticating using EAP over LANs. That's the method that it's using to take advantage of something like that. If you've used types of concentrators in the past, especially those from Cisco, you may be familiar with LEAP. LEAP has the L in front of the EAP. They called it LEAP because it's a lightweight extensible authentication protocol. It was proprietary to Cisco. You really don't see this much anymore because we've gotten out of the proprietary way of doing this. But back in the day, before we had come up with standards for doing this, before anybody really had started deploying wireless access points, large organizations said, we need a safe way to authenticate. Cisco, build something for us, will you? And they said, okay, we'll build something. It's not a standard yet, but we're going to call it LEAP, and it'll be just for Cisco devices. Very, very useful to have that there. Now, it does not have any type of things like certificates on a machine. I mentioned earlier, we could put a certificate, that encryption certificate on a machine. Really, it's just an identification certificate and be able to use that. LEAP doesn't do that. This is lightweight. It just uses passwords to be able to authenticate people. And it's based on Microsoft CHAP. There's a completely different conversation we can have about how Microsoft CHAP has some security shortcomings, but it got people on the network and at least was able to use some authentication. When you're dealing with wireless authentication these days, you tend to have something like PEEP, Protected Extensible Authentication Protocol. Now you know why there's a little chick on the screen. This was created not just by Cisco, Microsoft, RSA. They all got together and said, let's come up with a way that everybody could use that has a lot of functionality that solves some of these authentication problems for people. And one of the nice parts about this is it uses TLS to be able to encrypt all of the communication. So you're getting out of that Microsoft CHAP world. TLS, obviously, we talk about it as SSL. It's the same type of thing. That means we're putting a single encryption certificate on a server, and now we're able to communicate privately in an encrypted way to that without doing anything special to our workstation. That makes it really, really easy to implement. I put my encryption certificates on that one server, and now that entire authentication method is protected. That's what you want on a wireless network. And that's why EAP and specifically PEEP or PEAP is so nice to have available. Let's go to some of the questions that have come in about the exam itself. You know, it's good to know the content, but especially if you're sitting for this exam, maybe you've never taken one of these exams before, it becomes pretty important to know this piece as well. And so there were questions that came in. One from DW this week came in and said, do you have any idea when the test will update to the latest curriculum? Now, I'm not sure what latest curriculum means, DW, because there is this method that CompTIA uses to update their exams. And I understand the concern. You don't want to study for an exam and then suddenly show up and you're ready to take the exam and the exam changes. Now, what CompTIA generally does is they have a transition period, a migration period, where you can take more than one exam at a time. The current exam is the N10005. If you go out to the CompTIA website, you'll be able to see that exam. And from the perspective of the current version of the exam is the N10005. It was released on December the 1st, 2011. So it was out there since December, really the beginning of 2012. It really hasn't been out that long. It's been out just over a year now. So that becomes very useful when you're trying to plan out. That means if you look at in the past what CompTIA has done is they have provided the exam and put it out there for about 3 years, I think is about right. If we look at the CompTIA website, I just pulled it up here really quick so we could see. They will even say on the webpage for CompTIA, the current version of the CompTIA Network Plus exam was released December the 1st, 2011. And what they tend to do is they tend to update it every 3 years or so. So I'm really not expecting another update for the Network Plus for another couple of years. And then they'll release that one. There will be an overlap time frame. And then finally, that will be whatever the next one is, N10006 or whatever they plan to call it, will be the next one that they work with. So that's why for Network Plus anyway, you're on the latest stuff. You're talking about the latest content. You're talking about the latest pieces all the latest technologies, latest wireless, the latest encryption. All of these things are really the latest in the last year. Not much changes with networking. You don't have these dramatic updates to operating systems. Your protocols tend to stay exactly the same year after year. We add new types of technologies for encryption and new types of pieces for that. But that is one of the things that you need to keep in mind when you're thinking about what am I going to do with those, and am I taking one and getting the latest content, absolute latest content. If you're planning to take the Network Plus, go ahead and take it. It's going to be years before the exam is updated to a later version, so you don't have to worry too much about losing that piece. Another question, I kind of talked about this a little bit at the beginning of the study group, is I don't seem to understand subnetting. I just don't get it. And I understand. I understand exactly what you're saying. But is there a lot of it on the exam? And I ask this question not just because subnetting, but there's other topics as well. You're going through the topics and wondering, is there a lot of this on the exam that we need to work with? A good way to find out is to check yourself. And one of the best ways to check is to go out to the CompTIA website, that same page I was just on for CompTIA, and look at the exam requirements. In fact, I'm going to do exactly this. I'm going to first disable a few things so my private information isn't shown. I'm going to go to this LastPass screen if I click the right buttons here. There we go. So I'm on the Network Plus page. This is Network Plus. One of the things that they have on the Network Plus page is this Get Started Now. The first link is see what this exam covers. If you are taking a CompTIA exam and you have not gone to their webpage and you have not downloaded the exam requirements, stop everything you're doing with your studies, drop your book, stop watching the video, go out. Well, don't stop watching the video. Go out to this CompTIA website. There's also a link on Professor Messer. If you're on the page with all of the different videos, at the very top is a link to this page. If you go to professormesser.com/FAQ, there's a link to this page. This page is pretty important, where you can fill out your information for the exam objectives, and you yourself can download the exam objectives and have a look at those. Now, that's because the exam objectives are going to have a ton of information on these. I don't speak about these exam objectives because I think it's a good idea. I talk about these exam objectives because it's an enormously important idea. This is something you must do. So let's bring up the exam objectives on my screen. We'll have a look at them. This is the actual exam objectives. After downloading them, they not only tell you the layout of the exam so that you can see exactly what's there, but they also go through every single topic that they're going to ask you about. They stay very, very close to this. It is a huge document. There's 23 pages. You don't get this from Microsoft. You don't really get this from Cisco. You don't get it from a lot of places. This is a very, very detailed overview of what's here. What's great about this is you should read this before you start doing your studies. Before you take the exam, go back to this and start checking off what you know. Do I know the OSI model? Yep, check. Do I know the TCP/IP model? Check. Do I know about EUI64? Let me circle that one. I want to go back and look at that piece. Look at all the detail they put in here. Page after page after page after page. Zoom. Oh, we're really going to go fast because I want to get to the end of this. You'll notice that the numbering scheme here, by the way, 3.4 categorize WAN technology types and properties, and all these types, I use the same numbering. So if you're trying to figure out, oh, what's DS3 again? You go to the section 3.4 in my videos, that's what it covers. Just as an aside there, make it really easy for you. If I keep scrolling after you get through the exam objectives, I mentioned this earlier, there's an acronym list. So now I can go through what all the acronyms are, understand what their names are, and get a feel for, do I know what that means? Because it's going to come up. And the Network Plus exam, boy, there's a lot of acronyms there. There's a ton of acronyms on your exam. And it's one of those challenges that you get into when dealing with this, that there's a lot that you have to learn from those pieces. So, of course, go into the details of those, understand what those acronyms are, and you'll be able to make the decision on, is this something that I need to know? Are we going to cover it a lot? And as I mentioned with subnetting, somebody just took the test, didn't get any questions. You might get one, you might get two, but based on the numbers, based on all those things you just saw go by, subnetting was one of those. You saw pages and pages go by. Subnetting was just one. So don't worry so much about subnetting. It's going to be important that you know subnetting. It's important for networking. It's important for security. It will be important in your career going forward. You will learn it eventually. But for the exam, the basics will get you through. Don't worry so much about it. I would rather that if you're really stuck on it, that you spend time learning the rest of the content and get 10 other answers correct and that one wrong versus getting 10 questions wrong and knowing your subnetting. So that's the trade-off you have to make yourself. One of the questions was, where's the best place to see what the practical application questions might look like? And I think that's one of the biggest questions right now because they're brand new. People are just starting to use them on these practical apps. One of the things that I have in my frequently asked questions videos on my website is this list of these. I guess I should probably close my study group chat so you can actually see it. There we go. Frequently asked questions. One of those is what performance-based questions are on the exam. So you're going to need to know this, obviously. I go through what they are, and I speak to and talk about a video that CompTIA put out that goes through one type of performance-based question. And I wish that I had in some way grabbed, there was an earlier video they put out that had a lot of different examples on it, and I kind of missed those. They did like 6 or 7 examples, and then they realized, whoa, that's a lot of content. Let's pull that back, and they just show you one now. But that at least gives you an idea of what you can look at for those pieces there. And I think that's pretty important too. You want to be able to find all of those to have that there as well. So let's also have a look at an important piece. If you're learning networking, I think this is an important piece. Last month, I talked about what you can do to look at packets. Get on a network, use Wireshark, grab some packets, see what's going on so that you can get a feel for how your network is operating. Now, one of the things you may not be able to do is be able to do this yourself. So the link of the moment is one that is back on the Wireshark website, wiki.wireshark.org/sample captures. This is one where people have already put sample captures on the wiki. You can download them, and it tells you exactly what happened during that capture, and you can look at it yourself. Very, very useful to be able to do that. You want to see traces that have simple ARPs in them? You can see that piece. You want to see traces that have a voice over IP communication? Do you want to use Wireshark to decode that voice over IP and play it for you? You can do that. Those traces are right there. This is a little bit outside the scope of Network Plus. I understand. It's a little bit farther beyond what you would have to know. But as you go through networking and you really want to know networking and you really want to know security, you will do well to know exactly how to read those packets coming through the network. It's like reading a heart monitor. You can see everything. It's like the Matrix as it's flowing down the screen, and you can pick out and see things as it's going by that other people have no idea what's going on there. And understanding the way the network works makes you understand how the applications are working. It makes you understand how security should be implemented in those environments. A pretty important one to be able to work through. I think that's an important one there as well. Well, that brings us kind of to the end. We've had an hour and 15 minutes of study group this month. I want to send my thanks, of course, to you. If you'd like to see what we do the rest of the month here at Professor Messer, you can go to professormesser.com/YouTube. Twitter, you can find me at professormesser.com/Twitter. Google+, you get the idea, and Facebook. And of course, there's a new piece of this. I added a wiki to the Professor Messer website. We're just getting going. If you want to be able to get there, add some content. Maybe there's something you just learned, stick it in the wiki. It's right there. You have to get an account on the Professor Messer website, and you'll be able to add those. I'm going to start adding more myself. Everybody's starting to add them. I think it will be a very good resource once we get that really going again. Our thanks to GTS Learning. If you want to take advantage of that special pricing I told you about, you go to professormesser.com/netlabs. And of course, thanks to all you. We wouldn't be able to do this study group if you weren't watching, if you weren't sending your questions, if you weren't watching the videos throughout the month. It becomes incredibly important to have that there. I could not even imagine trying to do this without your feedback. I'd be sitting in front of a camera for an hour saying, so what do you want to talk about? I don't know. Yeah. But now I have so many questions come in. And what we'll probably do is we're going to close out the study group, and then we'll do an after show with some of the things that didn't quite make it onto the primary study group. So that comes in handy as well. Thanks again, everybody. We will see you next time on the Professor Messer Network Plus Study Group.